beyond chemistry.
Guten Morgen und herzlich willkommen zur Forschungs- und Entwicklungspressekonferenz 2024 von Evonik. Alle 2 Jahre ist es soweit, dann lassen wir Sie Einblick nehmen in unsere Labore, in unsere Innovationspipeline und so auch jetzt. Aber wir sind nicht am gewohnten Ort. Wir sind in Essen, der Stadt, in der sich bekanntermaßen unser Hauptquartier befindet. Aber wir sind im Norden der Stadt in einem rein digitalen, virtuellen 3D-Studio. Warum? Weil wir Ihnen unsere Innovationen natürlich gerne auf die anschaulichste, auf die plakativste, auf die innovativste Weise nahebringen wollen. Bevor wir damit loslegen, vielleicht einige technische Hinweise. Alle akkreditierten Journalisten können jederzeit Fragen stellen in unserem Chatfenster auf dem Conference Space. Wir werden diese Fragen sammeln und am Ende der Sendung gebündelt beantworten. Und wer der Sendung lieber auf Englisch, in englischer Sprache folgen möchte, der kann auch auf dem Conference Space die englische Simultanübersetzung anwählen. Was haben wir heute vor? Wir haben 3 Forschungsprojekte aus der Innovationspipeline von Evonik vorbereitet und mir persönlich geht das immer so als Nicht-Naturwissenschaftler. Wenn wir in die Recherche gehen zu diesen Themen, dann bin ich immer wieder beeindruckt, welche Breite und Tiefe die Evonik-Forscherinnen und Forscher so abdecken. Aber ich habe heute 2 Männer bei mir, für die gehört das quasi zum beruflichen Alltag und zu ihrem normalen beruflichen Einerlei. Das sind zuerst Harald Schwager, der stellvertretende Vorstandsvorsitzende von Evonik, im Vorstand für Innovation zuständig. Herzlich willkommen, Herr Schwager.
Guten Morgen, Herr Schwager, an unusual place. Did you find your way here? Well, yes, I think no problem. It's very impressive, the setting here, and I think that's the right place for the event. Next to you, there is the Chief Innovation Officer of Evonik, Ralf Marquardt. Warm welcome also to you. Is it a new experience for you as well? Yes, it's not the first time, but the scale here is new to me, and I'm very much impressed, of course. So innovation, of course, we are talking about innovation. We have lots of innovations here, and we are happy and looking forward to the event. First, we will provide you with the audience with an overview of the world of innovations and the strategy in order then to go into details. And here we begin with Harald Schwager, the Deputy CEO of Evonik. First of all, a very good morning, ladies and gentlemen. If you're sitting right in front of your computer, good morning. Let me start with something obvious. The world is changing at a drastic pace. Industry has to follow suit. Only then we will rise to the challenges of our time. However, what needs to change exactly and how? At Evonik, we are convinced that 2 notions point the way to a decent future, namely innovation and sustainability. We can only shape and design the future with new ideas. This is the only way to find the solutions for more climate protection. For a society that no longer consumes resources thoughtlessly but recycles them smartly, and for an economy that puts the people at the center without losing sight of the environment. I'm convinced the more we conserve resources and the more innovative we are, the more sustainable and profitable we will be. Therefore, I am happy to present our 3 new innovation growth areas today. With them, we intend to achieve additional sales of 1.5 billion euros by 2032 versus the baseline 2023. These growth areas designate 3 major mission assignments of our time. Advance precision biosolutions, accelerate energy transition, and enable circularity. Our Chief Innovation Officer, Ralf Marquardt, will present more details on this in a minute. The key themes, biosolutions, energy transition, and circular economy go to show. Our innovation growth areas are 100% about sustainability. This helps us to further grow the revenues with products that come with superior sustainability benefit. Last year, these next-generation solutions already accounted for 43% of group sales. We intend to raise their share to over 50% by 2030. For us, innovation and sustainability are no end in themselves. They are key elements of a viable business model for the future, and we are continuing the strategy with new growth areas. Ladies and gentlemen, 1.5 billion euros of additional sales revenues within 10 years is ambitious. However, I'm convinced we have everything we need to be successful, and we will achieve these ambitious targets. Among other things, this confidence is based on our present innovation record. For our 6 existing innovation growth fields, we have held out the prospect of 1 billion euros worth of additional sales revenues by 2025. In 2023, we had already achieved 650 million of this. Given the turbulent past years, this is a strong result we are going to build on. A pandemic temporarily paralyzing the world economy, a war right in the middle of Europe which triggered an energy price shock, such scenarios were unforeseeable when selecting the fields. The fact that we've already come so close to our target in spite of these partly unprecedented challenges shows that we opted for the right themes. This is demonstrated, for instance, by the growth trajectory of our membrane business. Evonik is contributing to the defossilization of the energy sector with membranes for the treatment of biogas or for the extraction of hydrogen. Last year, we commissioned a new production plant for Cepuran hollow fiber membranes at Schörfling in Upper Austria. Meanwhile, another such plant is being built. Another example are our biosurfactants. Many of you heard, certainly, that we inaugurated the world's first plant for the production of ranolipids on an industrial scale in May. We invested a triple-digit million amount. Now we are taking the green transformation forward in the cleaning and personal care industry with the production of biosurfactants by fermentation there. Some of you may even remember that we presented our biosurfactants for the first time at our R&D press conference in 2016. This highlights 3 facts. First, we have the expertise to select exactly those research areas which are successful in the market and make a true difference in terms of sustainability. Second, we have the stamina and patience to bring these projects to a successful conclusion. Third, we have the necessary determination to invest in our future and enable profitable and sustainable growth. All in all, we kept our R&D expenditure of 443 million euros on the same level as in the previous year. At present, some 82% of the expenses are accounted for by the producing chemicals divisions and 14% by Creavis, our research unit for the mid- and long-term horizon. This is equivalent to a research ratio of almost 3%. We are convinced that our innovations contribute to a sustainable future. This is why we are investing to take the green transformation of Evonik and our customers forward. When the world is turning faster, we lead the way towards resource conservation and sustainability. Thank you, Mr. Schweiger. I think at the beginning we had some sound problems and we had to switch to the hand microphone. Again, if you haven't understood anything, so please, if this was too fast, you can, of course, ask questions in the chat. We will answer them together afterwards. But we have twice the expertise here today. We not only have the Deputy CEO, but also the Head of Innovation, Mr. Marquardt, And we turn to you now, and please put your topic into context, and please also use the handheld microphone. So we're looking forward to your presentation now, Mr. Marquardt. The floor is yours.
Ladies and gentlemen, you've just heard the names of our three new innovation growth areas. When we developed these, there were two crucial questions we posed. What are going to be the challenges in economy and society in the coming years? And where can we, as Evonik, make a crucial contribution? I'm convinced the answer to these questions are to be found in the challenges we are going to focus on, namely advanced precision biosolutions, accelerate energy transition, and enable circular economy. Of course, we are not starting from scratch. No, by contrast, we are going to continue on a successful path and are doing even better. In each innovation growth area, you'll find a vast project portfolio, new projects from which we expect a lot, existing projects which have already been promising, and forward-looking projects from the former innovation growth areas. What they all have in common is that if we lead them to success, every single newly developed product will find its position in the market. Let us have a look at advanced precision biosolutions first of all. Biotechnology helps us to develop solutions for the cosmetic and the pharmaceutical industry, products which do not only health of people and life quality, but which also protect valuable resources and ecosystems. In the past autumn, we actually introduced a new adjuvant. The squalene used to be extracted from shark liver. We are now able to generate them on a plant-based production process. And the way biotechnology helps to develop cosmetic products with special properties will be explained by Stefan Pelzer later on. The key is in the skin microbiome model, by means of which, for the very first time, realistic products have become possible. With Accelerate Energy Transition, we are going to focus on the energy transition. The transition to the use of fossil energies towards renewables reduce CO2 emissions. But for genuine climate neutrality, this is not enough yet. We need to avoid emissions, and we also need to separate, use, and still CO2 emissions. With the high-performance amines, we are in a position to offer highly efficient combinations with silica. And we are also able to offer solutions for the segregation of CO2 at sources, as, for example, gas-powered power plants, and also directly from the air. We are developing additives which enhance the performance of modern insulation material, and this helps us to contribute to energy efficiency in buildings. Of course, we are also focusing on our own footprint. Patrick Stenner will report on electrodialysis, which has become a platform technology on the way towards green transformation. And the third innovation growth area is enable circular economy. Here we pool our research, focuses in modern circular economy. Catalyzer recycling is a focus in the chemical industry. As of today, we are taking back some catalyzers already and reprocess them for a second use. And this is a portfolio we want to further expand. Christian Marley is going to present some of our early research projects in this direction. By promoting recycling of tires, we will provide a hands-on experience to consumers. Ladies and gentlemen, our goal is clear. We're working on solutions on bio-based energy saving and circularity. Evonik will continue to further focus. We will focus our means and investments and pool our expertise. We will gear our research projects in a consistent way to these topics, and in the future we will also focus our resources towards existing fields of innovation growth areas, and we're convinced this will be the solution for a a meaningful future. With the new areas, we are working in order to be better networked, and this is why we extend our presence in the globally most important innovation ecosystems. Evonik Skin Institute in Singapore and the Cambridge Innovation Satellite in Boston are only two examples to this effect. This is how we can make sure that solutions reflect the current state of the art and science. The close exchange with our customers worldwide helps us to all needs in the market. We do support that by way of two further measures. The Evonik Sustainability Tech Fund of our venture capital, which in 2022 was issued with volume of 150 million euros. And we use it in order to invest only in startups which are matching our innovation areas. And the Strategic Innovation Unit Creavis, which is focused as a business incubator for mid and long-term projects. Ladies and gentlemen, the future of our society depends on resolving the challenges we mentioned before. I'm convinced that the innovation, Evonik, our knowledge and our expertise will contribute to create a world which is worthwhile living in. There are two concrete examples that will follow in the following presentations. Thank you very much. Thank you very much, Mr. Marquardt, for this bird's eye view on the innovation landscape proposed by Evonik. As you announced, we will look at some more concrete research projects, and Ralf Marquardt and Harald Schwarke will be available for the question and answer session later on, and also for the chat. Stefan Pelzer. Stefan Pelzer, he is the person at Evonik who is the expert in something that is very close to us, that's our skin. Not in that casual way I am presenting it, but in your presentations about the skin microbiome. What is it? For decades, we have known that our skin is full of bacteria, several millions as it were. The accessibility of molecular biology in the past 20 years has taught us how diverse microbes are on our skin and what kind of functionality they have. While bacteria, microbes do not have the best reputation, as far as I know, but if I understood you correctly, you're talking about the good ones. There's certainly bacteria that trigger diseases, of course, but what is important is to maintain a status where bacteria live in a balanced community, and those bacteria causing diseases can be controlled, and this is what we are looking into. Now, I think I understood the foundation. We have prepared a contribution which explains us in detail what Evonik is doing and what Mr. Pelzer's area is doing in that field of innovation. We'll have a look at this.
The global retail sales with cosmetic and personal care products totaled $460 billion last year. In 2027, these sales will already amount to $580 billion. There is great interest in developing products that are in harmony with nature. And this goes in particular for the up to 100 trillion microorganisms which live in and on us and are referred to as microbiota or microbiome. The cosmetics industry has realized the fact that we have to take good care of our skin microbiome. Therefore, it comes as no surprise that products have been launched in the market in recent years which always come with a claim in respect of the microbiome. You come across many products with a label like microbiome friendly or nice to the microbiome. Many of us do not know, however, that this claim is not based on a methodological consensus, and this makes it really very difficult for consumers to assess such claims. Today, I would like to present to you a new predictive skin microbiome model which we have called Skin Microbes. It is a model which consists of the 8 most important skin microorganisms and demonstrates the interaction of these microorganisms with cosmetic ingredients so that the claim of microbiome friendliness can be scientifically verified. Before I now present the model in detail, I would first like to describe a few facts on the skin and the skin microbiome. With a surface area of 25 square meters, the skin is the largest human organ, and it protects us from dehydration and pathogenic germs. The skin is made up of different layers. At the surface there is the so-called epidermis, below it is the dermis, with various organs such as sweat glands, sebaceous glands, but also hair follicles. By numbers, the microbiota are most widespread on the skin surface, but they also protrude to lower skin layers. Molecular genetic analyses have shown how diverse the microbiota is, and that it differs enormously from person to person. The microbiota is exposed to the impact of many influences. This includes the way we are born, our hormone status, the use of cosmetic products, and also our nutrition. All these influences have an effect on the skin microbes, and it is important that the skin microbiome maintains its natural balance. There are not only differences from person to person, there are different regions on the body populated by different bacteria. In fact, we have moist, warm skin, for example in the armpit, where we find in particular bacteria of the type Staphylococci, but also Corin bacteria, which may be responsible for the smell. On the forehead, in the face, we have an oily sebaceous skin. Here we find in particular those bacteria which belong to the Cutibacteria and Staphylococcus. On the dry skin, for example of the lower arm, we come across the greatest diversity and variability in the course of life. Here we find Corin bacteria and Cutibacteria, but also Streptococcus. You see that the complexity of this skin microbiome makes the development of a model to predict the interaction with the ingredients more difficult. And it is important that we do not only have one model to test the interaction of ingredients with individual bacteria, but we need several interacting bacteria, because this is the only way to make a statement on the interaction with active ingredients on a truly scientific basis. Bacterial reproduction is the precondition for interaction, and the bacteria on our skin form an interactive network. They can generate metabolic products, metabolites that is, which are the basis of interaction. In fact, some microorganisms produce metabolites that others need to survive. This is what we refer to as synergism. However, there are also microorganisms producing metabolites which inhibit others in their effect. We call this antagonism. Moreover, there are other communication and interaction possibilities such as competition, but also the interruption of communication. Therefore, it is extremely important for us to develop a model allowing different skin microorganisms to interact with each other. How has this been implemented in concrete terms? In methodological terms, we had to break new ground. This is why we teamed up with international experts, for example, the experts at the Center for Microbiome Innovation in San Diego. However, together we decided to develop a model in which 8 of the most well-known and most important skin microorganisms of different regions can be reproduced together. 2 things have to be specified for the determination of the effect of cosmetic ingredients on the microbiome. On the one hand, the bacterial reproduction, and on the other hand, the bacterial diversity. What does the concrete methodology look like in the laboratory? First, there was the great challenge of finding media constituents that allow the simultaneous reproduction of the 8 skin microorganisms. We successfully achieved this in a slightly acid pH environment. Not all the bacteria of the skin like oxygen, and this is why Mrs. Dagatz performs the inoculation at an anaerobic workstation. The test substances are also added here. This is followed by the incubation of the co-cultures. We use a high-throughput microbioreactor for this. 48 small vessels are in one disc in which the co-cultures with the test substances are agitated. This incubation takes 48 hours. After the incubation, we determine the different bacteria by way of a genetic fingerprint. We need the DNA for the genetic fingerprint. The DNA is also isolated by a high-throughput methodology by means of a so-called magnetic particle processor. Eventually, the specific DNA of each bacterium is quantified. For this step, we use a methodology, the so-called qPCR, with which we are still very familiar from the corona diagnostics. The results are available after 2 hours. We have thus created a high-throughput methodology enabling us to quickly analyze our active ingredients in parallel with great precision and a short throughput time. So much for the methodology, but what do the concrete results look like? The following figure shows the results of the qPCR as a measure of the reproduction. 1 control substance and 2 test substances were tested. The qPCR was plotted in a logarithmic scale, and you see that 800 million bacteria already exist in the control after 48 hours. The addition of an antimicrobial substance, however, led to a strong reduction of the overall growth by a factor of 1000. Whereas the addition of a mild surfactant had obviously no effect on the total number of cells in the culture. The cell total is one thing, but what about the distribution? Have all the species survived? This is shown in the following picture. You see by way of the different colors, which are specific for the respective skin species, that all microbes have survived in the control. By contrast, the addition of the antimicrobial substance has led to drastic reductions in the number of species. We only see one species which has survived. This is different when it comes to the mild surfactant. The addition of the mild surfactant did not have any drastic consequences for the distribution and diversity of the skin microbes. How can these results, which we've just seen, now be translated into a quantifiable statement on the microbiome interaction? First, we have to ask ourselves what microbiome-friendly actually means. The experts agree that a substance is microbiome-friendly if it does not significantly change either the reproduction or the diversity of a microbiome. This means that we need 2 dimensions for the evaluation of substances, as you can see plotted in the following evaluation matrix. Along the x-axis, it is the reproduction, which would be unchanged as shown in the middle, increased towards the right and decreased towards the left. Along the y-axis, you have the measure of diversity, and here we use a so-called marker, which we call Bray-Curtis distance. This is a measure for the inconsistency of 2 samples. It is 0 when they are comparable, when they are identical. It is 1 when they are highly dissimilar. By testing a large number of control substances, we succeeded in defining 4 categories of microbiome interaction. These are microbiome-friendly, microbiome-promoting, microbiome-changing, and microbiome-disturbing. As an example, you now see the 2 test substances which we analyzed before. These are firstly the antimicrobial substance, which was tested in 3 different concentrations, and you see that all 3 substances are microbiome disturbing. That is to say, very much change growth and diversity. Moreover, you see that the medium and low concentration of the mild surfactant is microbiome friendly, while the highest concentration also exhibits microbiome disturbing effects. Apart from the skin microbes model for normal skin, we are currently developing models mapping specific conditions of the skin. And one specific condition is the acne-prone skin. Why is acne so important and crucial for us? Globally, 9% of the population are suffering from acne, 85% of adolescents, and among your friends and acquaintances, there will certainly also be many people suffering from acne. The market for acne is significant. It amounts to $5.9 billion in 2023 and is growing by 5%. It will even reach 9 billion euros in 2032. The acne-prone skin is characterized by a strong change of the microbiome. Here, a subspecies of the Cutibacterium acnes prevails in particular, which produces metabolites triggering inflammatory reactions. Precisely for this oily, sebaceous and acne-prone skin, we've developed a specific model containing 4 different microorganisms. 2 Staphylococci, 1 Cutibacterium acne strain and 1 Cutibacterium acne strain isolated from acne patients. We also work with artificial sebum and artificial skin flakes integrated in the model to enhance the predictive capability of our model. This model enables us to identify substances which can specifically trigger or inhibit the reproduction of the subtype Cutibacterium acne of acne. We are also aiming to further enhance the predictive capabilities of our models. And this includes the combination of the skin microbiota with artificial skin tissues. Here it is a major advantage to have truly competent colleagues in Evonik Skin Institute in Singapore. They provide us with these artificial skin tissues. The combination of artificial skin tissues and skin microbiota enables the trilateral interaction among the skin cells, the skin microbes, and the cosmetic substance which we would like to analyze. In sum, it is safe to say that with the skin microbes model, we managed the challenge for the first time to cultivate 8 different skin microorganisms together. The established method offers high throughput, and we achieve results on microbiome interaction that are scientifically evidence-based. We now use the technology to develop new cosmetic ingredients with differentiation potential for our customers and eventually also for all of us as consumers.
Stefan Pelzer für diesen Vortrag, und mit diesem ersten Thema waren wir buchstäblich hautnah am Menschen. Ich denke, da werden wir nachher sicherlich noch Fragen zu bekommen. Jetzt gehen wir weg vom Menschen ein bisschen mehr in Richtung große Chemie, große Anlagen, und deshalb habe ich einen weiteren Gast hier im Studio. Bei mir ist Patrick Stenner. Herzlich willkommen. Hallo, Herr Wagner.
Sorry, there's a technical issue. The interpreters cannot hear the speakers. Sorry for that. We're trying to solve the technical problem.
Die Elektrizität mit der Chemie. Man kann mit Strom Reaktionen starten, man kann Oxidationsreaktionen durchführen, Reduktionsreaktionen durchführen, und das alles mit grünem Strom.
Das war früher aber nicht so. Ich glaube, das Konzept ist schon relativ alt, wenn ich es richtig verstanden habe. Und der grüne Strom ist jetzt sozusagen der Game Changer.
Green electricity is the game changer now, yes. Early in the 20th century, there were lots of electrochemical processes, but now this has been pushed to the background. But now the green transformation is in the focus, and therefore electrochemistry is going through a sort of revival. So big hopes are placed by Evonik on this, but what exactly Patrick Stenner would like to present to us and how the process works will be the subject of his presentation now. And we are looking forward to this now. Thank you. Electrochemistry combines chemistry with electricity. Right beside me you see an Erlenmeyer flask with a chemical. And the reaction is not started as usual, the second reactant, that is the second chemical or heat, but with green electricity. In the future, we at Evonik want to start a large part of our reactions with green electricity. Electrochemistry can in future make a major contribution to the green transformation of the chemical industry. One example is the water electrolysis as shown in the picture beside me. This process uses green electricity to extract the green energy source hydrogen from water. Electrochemistry is a sustainable and efficient technology. It reduces the use of chemicals because no second reactant is needed anymore as it uses green electricity. To some extent, you can even eliminate entire process steps when using electrochemistry. Electrochemistry makes it possible to recover raw materials. As a result, it is a technology for the recycling economy, or rather circular economy. When we use green electricity in electrochemistry, we can reduce Evonik's CO2 footprint even more. This is why electrochemistry is a next-generation technology for us at Evonik. Accordingly, electrochemistry is important for us when it comes to the transformation of the chemical industry. In the next 5 years, Evonik will spend a double-digit million amount to further expand our technology platform of electrochemical processes and products. About 20 employees are doing research in this field of activity at Hanau and Shanghai. Of course, electrochemistry is not new and has been around for quite some time. In the picture here, you see a detinning plant for tinplate of 1952. As early as the beginning of the 20th century, there were many electrochemical processes, but due to the fact that fossil fuels became cheaper and cheaper, electrochemistry was more and more pushed to the background. It was only used where there was no alternative. One example is the chlorine-alkali electrolysis, which is still around today. As a result of the green transformation of the chemical industry, electrochemistry is seeing a revival today, not only in industry but also in science. Electrochemistry can do such a lot. Chemical reactions can be controlled by electricity, oxidation reactions at the anode, the positive pole that is, or reduction at the cathode, the negative pole. Electrodes enforce redox reactions in electrolysis cells, and we have already seen one such example earlier on, namely the water electrolysis. There, the green energy source hydrogen is produced with green electricity. Another example is the lithium-ion battery. It is often used nowadays in cell phones and cars, and it is also an electrochemical reactor in which electrical energy can be stored. However, the focus of today's presentation is the electrodialysis. Electrical fields can cause anions and cations to migrate according to their charge to the anode, positively charged, or to the cathode, negatively charged. Salts can be split by electrodialysis. Electrodialysis is already used today to process drinking water from wastewater. Another example is the recovery of table salt from seawater. In France, electrodialysis is used very often to de-acidify juices and wine. In the chemical industry, we now want to use the technology to recover raw materials from salts and as a substitute for chemicals when setting pH values. Salts are turned into raw materials again. Electrodialysis can separate salts into anions and cations. Electrolysis can build new molecules so as to generate raw materials. And this actually pays off, depending on the price of raw materials and electricity. A good example is caustic soda. We expect the price of caustic soda to rise in the years ahead. In processes of the chemical industry, we often use lyes, such as caustic soda, or acids like sulfuric acid to set the pH value. This results in processed water, for instance sodium sulfate. Electrodialysis can now convert this sodium sulfate into the raw materials caustic soda and sulfuric acid. I would now like to demonstrate by way of an example how this actually works. Sodium sulfate, an aqueous solution, now comes from our production plant. It is fed to electrodialysis. It is injected in the middle between the anion exchanger membrane and the cation exchanger membrane. Here, shown in red, is the anion exchanger membrane, whereas the cation exchanger membrane is highlighted in blue. A bipolar membrane follows downstream of the two membranes. The bipolar membrane has a very specific function, and behind this there are the two electrodes, the cathode and the anode. An electric field is created between the two electrodes. The sodium ions start to migrate towards the cathode. They pass through the blue cation exchanger membrane and reach the bipolar membrane. Due to their charge, the cations are now held back. The bipolar membrane is made up of two different membranes, namely an anion exchanger membrane and a cation exchanger membrane. Water now penetrates into the bipolar membrane and the electric field splits the water into hydroxide ions and protons. The hydroxide ions now migrate towards the anode, but are then held back by the blue cation exchanger membrane and remain in this chamber just like the sodium. And now our first raw material, caustic soda, is created. A similar process happens on the other side. The sulfate ions migrate in accordance with their charge towards the anode. They pass through the red anion exchanger membrane and also reach the bipolar membrane, where they are held back. Water again penetrates into the bipolar membrane, is split up by the electric field, and protons leave the bipolar membrane but can only migrate up to the anion exchanger membrane so that they remain in the chamber and combine with the sulfate to form sulfuric acid. And this is our second raw material, which we extract from the sodium sulfate. The process is so efficient because hundreds of membranes can be arranged in series in a single unit, as you can see here. The entire unit is called a stack, and I brought along one of them.
Hier sieht man, dass aus zwei Endplatten besteht. Die sind aus Polypropylen und pressen nun den Zellenstapel in der Mitte zusammen. Und neben den Membranen braucht man natürlich noch einen Distanzhalter, um zwischen den Membranen einen möglichst geringen Abstand zu halten. Und dafür setzen wir sogenannte Spacer ein, die nur wenige 100 Mikrometer dick sind. Das Ganze findet also in der Mitte zwischen den beiden Platten statt.
And from our Technological Research Center. It consists of two end plates which are made of polypropylene here. In sum, we recover three raw materials with the electrodialysis. On the one hand, we recover the caustic soda, on the other hand, the sulfuric acid and the water, of course, from which we have captured the salt. All three material flows can now be fed back to the production plant again. Here we see the entire process once again. We have our production plant. From the production plant we obtain the sodium sulfate, an aqueous solution, which is fed to the electrodialysis. The electrodialysis uses green electricity to convert the sodium sulfate into caustic soda, sulfuric acid and water. All three raw materials can now be fed back to the production plant again, and we have a recycling economy called circular economy. The electrodialysis provides access to raw materials by recycling, and this is a contribution to decarbonization. The technology can now be used in many of our plants so as to contribute to climate neutrality. What is more, our life cycle assessment team found that the caustic soda produced by electrodialysis has a much smaller carbon footprint, about 2/3 less actually than the caustic soda produced by the conventional process. If in addition the electrodialysis uses green electricity, this value improves again significantly. The technology can be used for different salts. Potassium sulfate is an example of a salt which can be converted by electrodialysis. Potassium sulfate can be converted by electrodialysis into caustic potash and sulfuric acid. Caustic potash is a raw material in the production of methionine. Methionine is used in livestock farming to feed animals efficiently on a sustainable basis. Another example at Evonik is sodium chloride. Electrodialysis can convert sodium chloride into caustic soda and hydrochloric acid. Caustic soda is needed for the production of sodium methoxide. Sodium methoxide is a catalyst for the production of biodiesel fuel. Another process water arising at Evonik, which provides a fascinating application for electrodialysis, is the conversion of ammonium sulfate into ammonia and sulfuric acid. Sulfuric acid is used in the polymer polyamide 12, also referred to as PA12. The polymer is used in fuel lines of cars or in large volume pipes. We are already testing the method in various processes at Evonik today. In fact, with isofurandiamine, to be more specific, isofurandiamine is a feedstock used in the production of windmills. Ammonium sulfate arises as a spin-off in the production of isofurandiamine. This can be converted by electrodialysis into ammonia gas and sulfuric acid. First trials in the Technological Research Center have been promising. Another example is the production of precipitated silica. Precipitated silica is used in energy-saving tires. When producing precipitated silica, salts, acid and alkalis arise which can be recycled for the most part by electrodialysis. Evonik is exploring whether the technology can be used in a demonstration plant as early as next year. However, we even want to take this one step further and use the technology directly in the process. At present, we set the pH value of our material flows by adding caustic soda or sulfuric acid, depending on whether we want to raise or lower the pH value. Once the pH value has been set, the material flow is fed to the reactor, the reaction takes place, and we obtain our product and also our spin-off, sodium sulfate. The idea now is to use the electrodialysis technology directly in the process. We now pass the material flow through our electrodialysis. We have the bipolar membrane, which generates OH- ions by an electric field. We raise the pH value. The old ions are automatically captured by the anion exchanger membranes, and the material flow is fed to the reactor. The reaction takes place. We obtain our product and now do not have any spin-off anymore. There is no sodium sulfate any longer, so that we can even dispense with an entire process step. The next challenge is the scale-up of the technology and the service life of the membranes. Our biggest challenge, however, is to tailor the technology to fit our processes specifically. As yet, the technology is not readily available off the shelf. We at Evonik are working to transfer the technology to different material systems, like here in Hanau, or at our demonstration facility, actually, where we are working on the transfer to sodium sulfate. I'm convinced that the electrodialysis is an important lever to reduce the CO2 footprint. We have clear goals at Evonik. We want to cut the Scope 1 and Scope 2 emissions by some 25%. That is to say, from 6.3 million tons in 2021 to 4.7 million tons in 2030. We invest some 700 million euros in our facilities to emit less CO2. Electrodialysis also contributes towards these targets. We see great potential in the electrodialysis technology and expect that we can make about 20% of our processes less polluting and more efficient through the technology. For instance, by way of lower energy consumption, lower CO2 emissions, lower input of raw materials, and less environmental pollution through less salt. All of this helps us at Evonik, and it also benefits all of us as people. Thank you very much for the presentation, and with this we leap to our third topic for today. This is about tires. Next to me is Christian Manni. Welcome, warm welcome to you as well. Tires. This is something that all the car drivers trust in, of course, but this is a high-tech product when it comes to cars. So what are scientists actually interested in when it comes to end-of-life tires? It's a product which billions of people use, and therefore we can produce a big effect if we change and improve things in the production. And it arouses a lot of ambitions, of course. So, end-of-life tires, that was your research topic. This is the challenge we're confronted with. And no individual can do this alone. Evonik actually addressed this and try to actually look at sustainable raw material, and we set up a team that goes right across individual departments in Marl, in Hanau, and also in other places. And we took a detailed look, of course, how this innovation output is produced, and Christian Manni and his team are doing a lot of work in order to turn end-of-life tires into new tires. So let's have a look at it. Thank you. Mobility is an essential part of our modern society. It enables us to transport people and goods, connect cities and countries, and promotes economic exchange as well as social interaction. Today's standard of living would be virtually inconceivable without the permanent development of transport. Tires made of rubber play a very important role in this. They contribute a lot to the performance and safety of road vehicles, and they provide greater comfort. Without tires, mobility could not have developed to the level we are using today. About 180 years ago, Charles Goodyear discovered vulcanization. Today, the tire industry is a major branch of industry. The world market for vehicle tires is currently estimated at way above 100 billion euros annually, with a rising trend. At the same time, aspects like sustainability and circular economy keep growing in importance for modern mobility. We know that the industry is aiming at more sustainability, from raw materials to production, right down to utilization and resource recovery. To this end, leading tire manufacturers have already launched projects and subscribed to ambitious voluntary commitments. Many initiatives have been launched for an all-out sustainable production. The scale we are talking about here is enormous. Globally, several thousand new tires are produced every minute, and they all need to be recycled again at some point. At present, only a small share of about 1% is used for the production of new tires. About 45% goes into the manufacture of other rubber products and rubber sheets for playgrounds. About 1% is turned into pyrolysis oil, which can be used for other chemical products. And the major share, 53%, goes back into the generation of energy. If new alternatives can be found and the recycling paths can be improved, this would mean great progress for a global product. At present, waste tires are for the most part recycled mechanically. This means that rubber is granulated and ground to create powdered rubber. It is used for the manufacture of rather simple rubber products like running tracks or rubber mats that serve as protection for playgrounds. And there is a technical background to this. The problem is that a large part of the recovered powder does so far not match the quality of produced new rubber. The recycled rubber cannot be blended well with the produced new rubber. So far, the technical limit is already reached at a small share of approximately 5%. This is why it can hardly be used for tires. If the tire compound contains more than just a few percent of powdered rubber, the effect makes itself felt quickly in the mechanical properties such as tensile strength and elongation at break. This results in poorer performance and detracts from the safety of the tire under high stress, and this is clearly unacceptable given high quality and safety standards. You see that first steps have indeed been taken already to use recycled rubber for the production of tires. However, the methods currently used drastically limit the possibilities to recover more useful recycling rubber for the manufacture of tires. This is why we are working on an innovative process for the recycling of tire rubber. The aim is to multiply the share of recycled rubber material in new tires compared with present solutions, while at the same time maintaining the high performance and safety standards of a tire. In order to understand our new approach, we first have to take a brief look at what tires are made of. A modern tire consists of many materials, such as natural and synthetic rubber, steel, textiles, and other chemical additives. Here you see an example of an average composition of a car tire. All this taken together turns tires into modern high-tech products. All the components are carefully tailored to each other to meet the requirements in terms of rolling resistance, abrasion resistance, and wet grip. Rubber, therefore, has a key role to play when it comes to the performance of tires. Rubber is produced by vulcanization. The process with pressure and heat combines raw rubber and many other components so as to create rubber. Sulfur has a key function in this. In the compound, it forms a robust three-dimensional network of sulfur compounds and carbon chains. This cross-linking network provides the rubber with its elastic properties and makes it resistant to abrasion and aging. However, this stable cross-linking also restricts the recycling potential. This is because it is technically difficult to precisely break up again the compounds which were established by vulcanization before. This is where we came in. We wanted to find out how this cross-linked network can be broken up again so as to improve the potential for recycling. Here it is important to break up especially the sulfur compounds as precisely as possible and to leave the long carbon chains in the rubber as intact as possible. This process is called devulcanization and typically takes place in a special machine. It absorbs continuously powdered rubber from waste tires, processes and molds it strongly at high temperature. In this way, part of the chemical bonds in the waste tire rubber can be broken up already. However, this classical approach is not very precise. It does not make any distinction when breaking up the chemical bonds. That is to say, it does not only break up the sulfur compounds as desired, but also cuts up the long carbon chains in one go. However, long carbon chains are important for the quality of the devulcanized rubber. If too many carbon compounds have been broken up, the quality of the material is reduced, which restricts the potential to use it in new car tires. Evonik has found out that specific chemicals, vinyl silanes, can help preserve long carbon chains. Here in the tire rubber, silanes make sure that under predefined conditions, sulfur compounds are opened up more specifically and all carbon chains are preserved. This has an impact on the result of the recycling process. It has already been demonstrated on a laboratory scale that the recycling material recovered in this way contains much more well-preserved carbon chains than previously used solutions. And this makes it possible to use more recycled material in new tires. Now it is also better suited for the production of new tires. Tests have shown that it can be well incorporated into the materials mix of new tires and be vulcanized again. One strong point of the new approach, the silane can or could be easily used on existing plants to improve the process. This would make it possible without any major additional expenses to achieve much better recycling results of a high quality. Building on this research and development success, Evonik is currently developing a system of devulcanization aids. On a laboratory scale and in cooperation with universities, Evonik has already approximately quadrupled the share of recycled rubber compared with the existing solutions. Trade associations of the tire recycling industry still regard an addition of approximately 5% of average waste tire material as an upper limit today. According to first research results, the rubber devulcanized by our method has a high quality. Many measured values are comparable with those of new material. Accordingly, the recycled material can also be used in the manufacture of new tires. Can the new method be expected to provide high-grade material also on a large scale? This would be a technical breakthrough. Much more recycled rubber could then be used for the production of new car tires than before. And it would even be a success that could be achieved without detracting at all from the safety and performance characteristics of new tires. Following the successful laboratory experiments, Evonik now intends to successively scale up the process and to take further steps towards practical day-to-day applications. Corresponding tests and trials are to provide additional insights. The aim is a better recycling solution which our customers can use also in industrial production. Should this be successful too, our innovation could overcome narrow old limits in the recycling of tires. Once successfully implemented in industry, the new process could make a contribution to more sustainability and circular economy in the mobility sector. More recycled and high-quality rubber in tires would reduce environmental pollution and conserve resources. With the recycling, Evonik also comes full circle. Our products have made green tires possible for years. These are car tires which cut fuel consumption by up to 8% compared with conventional tires. So our innovative silica silane system has revolutionized the production of car tires. So we have already been providing solutions for better production and use of car tires. Now we are also committing ourselves with the recycling of waste tires to a better innovative solution. Evonik itself does not produce or recycle any tires. We are committed to specialty chemicals. We provide knowledge, expertise and specific know-how from the chemical industry to make better products and processes available in many industries. We already manufacture a range of products for the tire industry. We will continue down this path by way of research, innovation and development. Climate protection and sustainability are global concerns. The EU, for instance, intends to become carbon neutral by 2050. Renewable raw materials, circular economy and sustainability are issues globally. This requires compelling technical, economic and ecological solutions in many fields. Evonik intends to develop a contribution to this with a new devulcanization method. It is about a sophisticated method meeting high technical requirements and quality standards in tire production. Raw material cycles and economic efficiency are no contradiction. Our efforts are aimed at recovering rubber by way of competitive recycling. The results speak for themselves.
That was our third presentation by Christian Magny. Time for questions. Your questions were received in the chat room, and I'm very much looking forward to have all the competences of Evonik in front of me. Welcome to all of you, and let's fire ahead. First questions relate to the overarching framework. So I'm looking at Mr. Schwager, Mr. Marquardt. Let us start with questions by Bert Frenthoff from the Handelsblatt. Mr. Frenthoff is asking for answers one after another. Question: what is Evonik's structural approach in order to get more innovation? How were and are internal, external development structures being improved? Well, I could actually explain to you that from history, we used to have a very decentralized research. As you know, we have talked about that several times. And in the last step, research under the leadership of Mr. Marquardt has been concentrated, and research from the FN unit has been made accessible to all divisions and different regions worldwide. And due to this, and thanks to this pooling, I'm not saying centralization, pooling, we were able to enhance efficiency and efficacy. That is the major structural change we have done in the past years. And in a layer below, we have refocused our topics, we have adjusted that, and you have learned that from the new innovation growth areas. We used to have a similar situation in the past. I did mention it in my presentation. Maybe Ralf Marquardt can go into detail. Something quite important was to be represented in worldwide innovation topics, and I did explain that for this purpose in Singapore we founded our Evonik Skin Institute, and together with the Cambridge Innovation Satellite we are in the Life Science Cluster Boston, and this is where the different therapeutic auxiliaries can be better researched. And this way, we are much closer to the worldwide innovation centers, much closer than in the past. And a very important structural element is our fellowship program. So internally, you can step up the career ladder if you have a major expert commitment. We've got 2 fellows present here in the room who are partly professors at universities, at the same time lecturers at universities, and that's how they're very close to most recent developments as well. 2 examples. And then the venture capital funds is investing in startups and is observing the startup landscape, especially in the area of sustainability. And this is a way that helps us to observe and discover interesting developments we can share in or invest in. Let me link up with the second question. Pooling and not centralization, Mr. Frenthoff is asking. Will FNE especially be expanded abroad? What kind of networks is Evonik building there? And will the German side lose in importance? Now, it is a question concerning the time horizon. When we look at the beginning of Evonik, our predecessor company, we see that 100% of research was located in Germany, 100% of production was located in Germany as well. We developed things further over the decades and we will continue to do so. So the plan is, and it's partly being implemented already, it is planned that the relative share in research expenditure both will increase. So it's the relative share. It has to be increasing to the extent that our product implementations and sales are shifted into other regions of the world. So in future, also an increase in relative shares in research investment abroad, outside of Europe. That's one point. And the other question is what's happening in absolute terms. And this is depending on the speed a company can grow with. How fast will Europe grow? How fast will the other regions grow? We know that we are, so to speak, living in a slowly growing region. The other regions, South America, Asia, have got higher growth rates. And this leads to a situation where simultaneously with an increasing absolute share, the part of expenditure in Europe in the past years has remained stable. The way it's going to develop in the years ahead will clearly depend on the political framework conditions in the regions, will depend on the development of growth rates as well, and we all know that Europe has got some deficits here. Next question to the head of innovation, because that is particularly part of your daily life. How do you secure competences, skills? Do you still get skilled workers for research in Germany, skilled people? In Germany, we've got excellent universities. We have internationally trained scientists, and we've got major research institutes. Just think of Max Planck and Fraunhofer Gesellschaft. In order to be in exchange with the universities, we especially focused on the presence in universities. I did mention the fellowship program already a few minutes ago. Many of our fellows, as it were, are lecturers, professors at universities, are actively involved in university life, and this is how we secure access to skilled people. Fortunately enough, I can say this is not my biggest problem. Well, to what extent the budget is sufficient is a different kettle of fish, isn't it, between the head of innovation and the management board. We'll leave it open, but I do hope that the first questions were already answered. If not, please check again and use the chat. I did assume previously that innovation growth fields, innovation growth areas might not be so clear as far as the difference is concerned. And Thomas Janssen from FSZ confirms my question. He's saying, I did not quite understand the delta. You're talking about 1.5 billion additional sales. In the press release, there was another comparison. 1 billion euro additional sales should be realized within 10 years by way of sustainable solutions, etc. In 2023, this value was around 650 million. So we are at the two different sides. Let me take on this question. In the past already we've talked about the questions. Those who were present in 2017, when I had the pleasure for the first time to talk about the 1 billion additional sales we wanted to realize until the end of 25. This is that 1 billion that is for the past decade. The 1.5 billion relates to the coming decade, and basing on 23, reaching until 32. The 650 million we've achieved is what we based on the former growth fields despite pandemic, and we are happy with that, and in the next 2 years we will continue to increase this number. But we're already starting on the basis of the new ones, and this is a phase that will reach into the next decade. It goes to show our endurance, our consistency. We didn't change every 3 years. We are continuing reports on a decade period, and from my point of view, this is appropriate for research activities. I hope you understood the difference now. Thomas Jans is asking, could you explain to us again what parts of research will not fall into these categories, or are we only doing research in topics that are included in the new innovation growth areas? No, we can't afford that, because a major part. Well, we have a major vehicle pool with major large-scale plants, and this is why a major part of our research expenditure must be invested in the improvement of existing processes. So this is one area where we will have to make progress in the future as well, but also investing in existing businesses. And I'll leave the word to Mr. Marquardt.
So you are familiar with our product methionine. Of course, we always have to keep improving it. First of all, we have to make it more efficient, but also we have to prepare for the green transformation. So these products will continue to be around, but they have to be produced in a carbon neutral manner. And therefore, we have to do a lot of research for our existing products, of course. By the way, this kind of research is defense research on the one hand. That's very important. Like in football, you have to have a good defense and a good attack. I think at both points, both fronts, you have to be actively involved. Of course, we have to have one analogy from football here. Last question of Jonas Jansen. I mentioned this before. It's about an increase of the R&D ratio. Would this be needed to achieve the goals? Would the investments have to be increased in general? This would the existing sales not just have an impact on the ratio? This is a justified question. If I look at you and then this is the absolute expenditure and the relative expenditure has to go up. On the other hand, of course, we have to see this goes hand in hand with the growth in sales revenues and earnings. And in particular, therefore, I'm happy that our innovation growth areas have taken a good development because this demonstrates that the innovative strength is enough and sufficient to actually drive additional sales revenues. This gives our researchers good arguments. The absolute amount and the ratio can thus be increased. But what's most important, it has to fit in with the economic environment. And the last 5 to 6 years, we have seen enormous challenges here. And in this phase, the absolute level was kept constant. And as you are saying quite rightly, the ratios, of course, in those years depend on sales, and then they went slightly up or down. Important to us is that we could actually then also, thanks to increases in efficiency, could be continued up to the present day. We could actually carry them out so that the results were actually produced. R&D ratio. This is, of course, in the minds of many people. Ralf Heinrich von FAZ is asking the following question before we come to the individual presentations again. Alex Scott from Chemical News, that goes to Mr. Schwager. Could you approximately say what share of your R&D spend is on your target growth fields, fermentation, electrochemistry, and on products to enable the circular production of oils, and other certain fields of R&D that you are now moving away from? That's by Alex Scott. This last part was mentioned before, but a couple of numbers and figures, an order of magnitude. Dear Alex Scott, of course, I understand your curiosity. And of course, you'd love to hear a figure, a concrete figure, as to what share we have out of the 443 million is accounted for by the new fields, but for competition-related reasons, we cannot communicate this figure, of course. But these are the rough R&D expenses in 2024. That is the first question of Ulf Meike from FAZ. What does this correspond to in terms of R&D spend? Mr. Marquardt can give you an exact answer because he knows what the development has been so far during the year. But in the end, there will be just under 3%, between 2.9 and 3%. This is the current R&D ratio. So let's go through the numbers. You also asked about the employees working in R&D at Evonik, what the development has been and how many of them are based in Germany. This brings us back to this topic of centralization. So relative question, 60% are based in Germany. The others work on a global basis, but of course we have to look at the bigger picture. R&D also includes other fields, not only the classical ones. This also includes the application technology and the process engineers. They work in large part also on the research topics. So if you include all the costs and all the people involved, you end up with 2,800 people, depending on what year you focus on and what the intensity was that the other departments contributed. So that's more or less stable trend, yes. You can see this also from the cost. Ulf Meinke, of course, looks in detail at our company. Evonik Tailor-Made is coming up. So what will be the impact of this on R&D? As in all the other areas, we will, of course, make sure to have the right numbers of hierarchies and the management span. Going forward, we will also internationalize even more. That's one building or one area of activity we are working on. And then the structural changes in R&D with respect to levels of hierarchy and management spans will be addressed in the same manner as in all the other units, but the R&D target will be defined, and then on that basis we can see what projects can be taken forward in the years ahead. An add-on, Evonik Tailor-Made is about a reorganization program for the group that will make sure by the end of 2026 that Tailor-Made will bring about a tailor-made administration in the group encompassing all the areas, including research. So much for that. If you are not familiar with this, then the next question is a rather general one. Maybe to Mr. Schwager first. Is the economic strategy towards climate or carbon neutrality, Green Deal, decarbonization currently a good narrative? Or is this something that actually would chase the financial markets and investors away? So there may have been some changes that we have seen here in recent months. I'm happy to answer that question. We should say the other programs will be delayed by 30 minutes now, because this is a very broad-based question, a very general one. Let me try to actually answer this in just a few sentences. First of all, we would like to talk about defossilization rather than decarbonization, because this is based on carbon, and chemistry lives on carbon because it's inconceivable without carbon. We need energy, of course, in a form that is produced without CO2 emissions, if at all possible, going forward. But you were asking about the narrative. Yes, it's a good narrative, and it will always be a good narrative, especially in the light of the flood situation here in Europe. This is becoming very clear again. I think the question cannot be answered without looking at the timeline, because we have an energy supply system that has been established, that is very centralized. It took us more than 100 years, trillions of Deutschmarks or euros or dollars, whatever, were spent on it. And we are now just for decades trying to actually revamping and restructuring this energy system to a decentralized, distributed system. And this has to be combined with an industry like ours, the chemicals industry, that needs large amounts of energy and is placed in various locations all over the world. And this takes time. The narrative you're talking about, in my mind, in my opinion, is characterized by short periods of time. It was influenced by certain topics and subjects, and has had a certain amount of volatility, whereas we've been talking about this a number of times before, we have to think in decades. With many of our products 10 years ago, for instance, the rhamnolipids, the biomembranes, for instance, we've worked on that for more than 10 years to get to the point where these products can be launched in the market. And it will take us more decades in order to scale them in such a manner that in the overall market it goes beyond this day-to-day business. We have a great need for investments, which is going up gradually. And if we actually move away from the path, because the narrative at a certain point in time points in the wrong direction, the straight line of our trend remains correct. And therefore, Mr. Kapp, we will actually in 2050 have to be carbon neutral. Maybe I get onto that. Maybe nobody is really aware of it and doesn't realize it. But for research 2050 today, if we have to develop this, which at some point has to be firmly in place in 2050 for carbon neutrality, this requires a lot of effort. Therefore, we have to look ahead. We have to look into the future, because the times that we need are very long, and these are fundamental developments.
Let us look at one of the projects in more concrete terms, and it is a kind of proof of concept. The next question is addressed to Patrick Stenner, comes from Alex Scott again, chemical engineering use. He's asked, how many energy can an integrated electrodialysis process in comparison to conventional process save? And second question, are you thinking about electrodialysis technologies to be licensed? I can't give you a concrete value because it very much depends on the plant and the application and the use. Electrodialysis is a circular system. We want to convert time currents into raw material to reuse them. And with sodium sulfate, we want to achieve a better CO2 footprint by way of the system, and this is the savings potential. But we do not want to license the processes. We rather would like to use them in-house. In-house, 2/3, that is a major lever. Do you have other examples, or is that the most concrete example? This is the most concrete example in the context of CO2 savings. Next question to Christian Manier. Manier with Process is asking, Mr. Manier, in your presentation you mentioned 5% as an upper limit for recycling rubber in the tire production. To what extent that could be shifted with the help of vinyl silanes? That is a major challenge posed to us. The part of recyclates in tires to increase is confronted to certain limitations, chemical and physical ones. In the laboratory, we saw that the share can be increased up to 20% without impairing the performance. And this is our objective. We want to maintain performance, quality and safety whilst increasing the share of sustainable raw material. This is complicated, as we saw in the presentation, but it's multiplying by 4 the rate according to the state of the art at the moment would be possible. Excellent. Michael Räuber from ChemManager, and this is addressed to the two gentlemen at my right-hand side. The application range of Evonik innovation activities is vast, starting from end-of-life tire recycling up to energy generation and vaccine formulation. Are there any synergies on which side, the chemical or the technological one? Or do we have to find a new definition for specialty chemistry? What would be your definition? The easiest definition would be products that are of increased sustainable use and allow for higher profitability than the ones that have to be replaced. This is the simplest definition of specialty chemistry. Then the question about synergies. We talked about structural changes, and I'll let Ralf Marquardt explain to us what the examples are. I would like to mention the following. If you try to describe our links, then one of the big elements would be particulate design. We're a worldwide leader. We can design particulates for most various applications. In the treads of tires, for example, silica particles are integrated. Then the lipid nanoparticulates are the carriers that transport vaccines. And a third example, in the so-called additive production and manufacturing, we have a special polyamide 12 powder, which is ideally used in order to be applied in 3D printers. This is one of the major core competences, and the other one relates to surface effects. We have a thorough understanding of surface effects, where small amounts of substances can the ever so efficient polyurethane matrices, for example, we produce substances which make sure that the polyurethane matrices have the pore structure which gives you a positive effect while you're sleeping. So these are the two most important core competences we pursue on and develop in two different chemical areas. And the question to the type of technology or protection platform we are using is not the most important one. What I mentioned are the two overarching elements, the fields of competence. Yes, thank you. I do see one comment. So once again, if you have any further questions, please go ahead. And if something has not been clearly answered, please check again. We have Cap once again. You said fossilization. Yeah, this is mixed up quite often. So thank you very much again for putting it into more precise terms. Otherwise, I do not see any further questions in the chat. Let me look around. Doesn't seem to be the case. So, well, of course, we are available after this conference as well. We know these were 3 very detailed presentations, very dense, but we are available to answer questions also afterwards. My communication team and myself would be available. But Mr. Kipp is asking again on the skin microbiome. Did I understand correctly that essentially Mr. Bell said about cosmetical products, but the pharmaceutical industry is actually searching for models which can avoid animal experiments? Is the understanding of microbiotic networks not a good call in order also go towards intestinal microbiomes and pharmaceutical industry? Well, microbiome research is a platform which was used for intestinal microbiomes for additives in animal feed or nutrition as well. We started off with that. And what we learned in the modeling, in the process of understanding microbes and transferred that to skins in order to develop models. Per definition, the cosmetic ingredients cannot be used as therapeutic means, and we do not plan to use them for pharmaceutical developments at the moment. The findings, however, could be used for this purpose. Okay, we'll take that along. Thank you very much. Right, I think there are no further questions in the chat. So once again, my offer, if you've got questions subsequently, questions on the individual expert presentations or questions on the overarching innovation strategy issued by Evonik, we are available either my communication team or so together with our experts. But we thank you all for coming here and for answering questions, for presenting your topics, and thank you to you, the audience, for your interest, the time, and stay with us, and we will keep you posted. We will continue to listen to questions from the media and would like to answer. Thank you very much so much on the Research and Development Press Conference by Evonik 24. Have a nice day. Bye from Essen.